So the last speaker of the day is Olivier Goffart, and he's from Woboq, and he's going to be talking about using namespace std.
Thank you. So using namespace std. So this talk is about using both Qt and the standard library. So the title is just a play on the keywords, but I don't really want you to write literally using namespace, or you do what you want. But anyway, so this presentation is about using Qt and the standard library. So who here tries all the time, if there is an equivalent in Qt, always to avoid using the standard library? Who is trying to always use Qt and never the standard library? Raise your hands. Oh, not as much as I was expected. Who here on the other hand really love the standard library and is always complaining, why is Qt doing their own containers? Why do they have to reinvent the wheel all the time? Raise your hand. And so everybody else is in the middle, like, okay, it's okay, you can have, I can use both. And so my talk is about I hope you will learn both about the standard library and about Qt in this talk, and about using them together. So I'll go make an overview of the differences between Qt and the standard library. Then I will talk a bit about the algorithms, the containers, and some other classes. But before, let's start to talk a bit about me. I started with Qt through KDE. Then I was hired by Trolltech and Nokia. And now I'm the co-founder of Woboq, and we're doing consultancy. If you need help to get your Qt bug fixed, come to me. While working in Trolltech and Nokia, I did a lot of work on Qt in many areas, including that I designed and implemented the new connection syntax in Qt5, and I'm still maintaining mock. But enough about me, and let's talk about Qt, about a bit of history. Qt started in the 90s. The first release of Qt was released 2 years before the standard C++ was first normalized. At the time, there was no standard library. Every project who was writing C++ had always to rewrite their own lists, string, anything, because there was no standard library at the time. It's only since really the standard library is there that it exists. So obviously, when Microsoft Visual Studio 6 was released in '98, Microsoft, as usual, always delayed, didn't really fully implement the standard at the time. Qt4, released in 2005, still supported Microsoft Studio 6, and some other compiler which had a very bad support of the STL. So Qt4 could still compile fully without the STL, and Qt5 keeps source compatibility with Qt4, so we couldn't, of course, get rid of our Qt classes. But Qt4 makes use of Qt. But Qt4 makes use of the STL internally. Qt5 uses the STL algorithm, but we still do not expose the STL in the ABI. What's the ABI, you may ask? So I forgot that if you have any question during any time, you can just raise your hand and I try to answer. So the ABI is the application binary interface. It's the interface between a library and an application at the binary level. So imagine you write a function like you use qline-edit setText, which takes a QString. To the developer, it looks nice C++, but to the compiler and to the linker especially, it looks, because there is overload, everything, it looks like this, as a symbol. You don't have to understand what this means. It's mangled. But the point is that there is the arguments are in there. So this function in the library, it expects a QString, which is layouted in memory like a QString, and where the data is. However, imagine we have had setText that takes std string. Then the mangling is a bit different, depending which standard library do you use. You have the short version here because the GNU library is shortened, but the LLVM libc C++ uses put the standard library in a namespace, so in an inline namespace, so the symbol is different. But not only the symbol is different, but also the content of the std string is different. How the memory is layouted is different from implementation to implementation. So GNU, libstd C++ and libc++ are two implementations of the STL. Basically, every compiler comes with an implementation of the STL. The thing is that the compilers are compatible with each other, so you can run Clang with the libc std C++ from GNU. That is not a problem. So Qt choose not to have the standard library in its ABI. The reason for that is that if you compile Qt against, say, the Clang library, or say you compile Qt against the Clang library, you have a binary of Qt, you can still compile your own application with the GNU library and the other way around, and it's still going to work all together. So that's the reason why Qt decide not to use the standard library in its ABI, and it's basically, that means it's public function in a way. So some function, if they are inline, they can use the standard library, but any function that is not inline cannot use the standard library. But the problem with that is that for every thing, we have to reinvent the wheel. So we cannot use std string, so we have to come with other classes. We cannot use std vector if we want to pass it to some API, so we come with our own classes. And yes, so now, for example, there is no equivalent yet to std function. Maybe we will have to make a Q function for it. That's the unfortunate part. Is there any question about the ABI or anything? So let's move and go to the difference. What would you say is the biggest difference between Qt and the STL? I draw here a camel and a snake. So you probably know about camel case, and also the thing is called snake case, which is with underscores. So one difference is the coding style, really. Some people say the underscores are so much better and more readable, but others say they add too much space on the screen, but really it's two different things. That doesn't really matter. Apart from the coding style, the STL and Qt have slightly different goals. The STL tries to be really general purpose and designed for everything. So it doesn't matter if you're writing a server, a game, high performance computing, or even a UI, you can use the STL. Qt, you can also use it for all of this, but its focus was really to make C++ easy to make a user interface. So you can see here I have put on the screen the signature of stdmap and qmap. You can see the difference is that for the standard library container, for all of them you can customize the allocator. It's not something that is very well done. Who of you already has customized its own allocator for any customer? So there's still some. So it has some used, but it's not so common. So that's what the STL does. Because it has some use, then it's possible. But Qt said, OK, it's not too common, so let's not care about that. So with the STL, you can customize much more to do more things. So for example, in QMap, if you want to have your own, if you want to have the keys sorted with case insensitivity, so you don't care if it's lowercase or uppercase when you sort, then you need to write your own case insensitive string. While with stdmap, you would pass a special allocator. And same with everything. You can configure a lot with the templates arguments if you need to, but in most cases you will not need to. So they have default that should be good enough, but you cannot do that with Qt. Another things are the naming convention. Say you have a vector with a number of elements. How do you get the number of elements in a vector with Qt? Which function do you call? Sorry? Length, yes. Any other? Size. There is a third one. Yes, so there's 3 options. So I would like to make a little poll here. Who prefers calling count? Who prefers calling size? Much more. Who prefers calling length? Very little. So many prefer calling size, and that's the equivalent in the STL. So the thing is that Qt say, okay, some people come from Java and prefer calling length. Some people come from C++ and prefer calling size, and some other, I don't know where they come from, but they like count. So Qt has many options and many convenience. So for example, if you want to append something in a vector or in a list, you have all of those options. What if you want? Which one can you use in the STL? Pushback, correct. That's in place back is another thing, but yeah, no operators. That is with Qt. It was only const begin, and then the STL added in C++11 cbegin, so you can also call cbegin now in Qt. If you want to access an element within a vector with Qt, you will use that operator, bracket, or @ What will you use with the STL? So you can use both, but they are different. I come back to that later. And in Qt, you can access an element even if it's out of bound, and if it's out of bound, you get a default constructed object. Is there with the STL, what do you do? So there is no such thing. So Qt adds some convenience as well. And so there is some more example, but what we see is that always the Qt takes the one from the STL, and sometimes there is some convenience that are added that do not exist in the STL. So as an advice, I would recommend that when you're mixing code from the Qt, when you're writing code that is mixing Qt and STL, you prefer the STL style, so then you have more consistency. And as I said, there is a small difference between @ and the operator bracket. In Qt, if you call the operator bracket, it might make a copy if your container is shared. So in Qt, you should prefer to call @. It's because you want to avoid copy. It's expensive. But with the standard library, @ does a runtime bound check and throw an exception if it's outside of the bound. So with the standard library, it's slightly faster to call the operator bracket. But so to play safe, I would call @ because it's really bad if you have a copy you don't want to. While if you have only one check more, it might not be too bad. But the point is that depending if it's std vector or q vector, it's different things that is the faster. So another big difference between Qt and STL is that in Qt, most of the containers are implicitly shared. So are you familiar with the concept of implicit sharing? So most of you are familiar, but I'm still going to go over a piece of code to explain what implicit sharing is. Imagine we have this code, we take a string, we assign it to hello world, then we take a second string, that is a copy of the first one, and then we append the the exclamation mark at the end of str. So first question, to see if you follow correctly, will str2 have an exclamation mark at the end? No, correct. So we make a copy. So what happens at the first line, we make the string str, which points to in the memory we have. So QString is just a pointer, and the pointer points to some region of memory which has the string, and it also has a lot of some metadata, including a reference count here. It's 1 because there is only one pointer to this string. At the line 2, we make a copy of the string, but making a copy of the string is extremely cheap. We just copy the pointer and we increment the reference count here. And then at the line 3, when we are going to add the exclamation mark at the end, we're forced to make a copy of the string to add, because otherwise if we will add it there, both str and str2 would have the exclamation mark. So anytime we call a non-const function that is going to modify the string and that the string is shared, we are going to make a copy. It's a copy on write. So if I continue with the algorithms, so that was the main differences between Qt and the STL that are common to most of the containers. Most of the containers in Qt are implicitly shared, and almost none are implicitly shared in the STL. So the algorithms, if you're familiar with Qt, the way to sort a vector in Qt is to just do qsort my vector. However, this now is deprecated. The reason is that Qt has other things to do that re-implementing their own algorithm. They don't appear in the ABI, so they don't need to be. They can be used directly in Qt. And for this reason, the algorithm in Qt 5 have been deprecated, and now you have to use, or you can still use the ones that are deprecated, but it's recommended to use the one from the STL. And the ones from the STL are a bit less convenient because you need always to write begin and end. So begin is an iterator, so it's a sort of a pointer to the first element of the collection, and end is an iterator to the element after the last one. But the main point is that all the standard algorithms works perfectly fine with Qt containers. Yes, there's a question.
Are you talking about all versions of Qt?
So my talk here is mostly about Qt 5. Because the question, if I understood correctly, is yeah. So the question is if it's true for Qt 4 or for all versions of Qt. So my talk here is about Qt 5. So in Qt 4, this is also true. But yes, that's a good point. But yes, the standard algorithm also work with Qt 4. In the very old version of Qt 4, Qt 4.2 or something, then it would have been slower, but because std swap and qswap were totally different, but now since recent, like Qt 4.7 or I don't remember, qswap called std swap, and so they're equivalent.
What about range for loops?
I come to that. So what does this code do? So it might not be obvious, but if I show it like this, it basically remove the items from, it remove if the priority is smaller than the threshold. So this is basically the way you write remove if with a standard library. If you're not familiar with it, it might look strange, but it's kind of a pattern. It's always remove if, and then begin, end, condition. And the thing is, remove if returns an iterator to the new end of your list. So remove if will not, strictly speaking, remove the element. It will just move all the elements and pack them together, and then you can erase all the ones. You can actually reduce the size of your list with arrays at the end. But this is really a pattern that when you're familiar with a standard library, you know this. And the point is that normally you should be able to read this code quicker because you see, okay, this removes if. Well, in this code, you really need to parse the while loop to see what it does and so on. Notice also that what's the complexity of this code here? So arrays is linear, and it's in a while loop, so it's going to be quadratic, while this code here would be linear. What does this code do? Yes. Copy if. So copy if works with a input iterator, and the way to insert thing in a list or in a vector with an input iterator is to use std back inserter. Again, it's a pattern, and there is many of them. So here, you probably know c++reference.com. It has here a list of all the algorithms, and I recommend you to go to this page and browse a bit and look at what the standard library contains. It has very good examples that you can use to implement your things and to use the standard library. And so the recommendation here is to use standard algorithm instead of rolling your own loop, as so you state the intents of your code. In C++17, you might be able to do what Qt was doing already 10 years ago, std sort my vector. If the ranges go into C++17, which I think will be the case, or at least part of it, enough to type std sort. Because the ranges is a big proposal with also a lot of cool features when you can really do functional programming in C++. Let's move to the containers. So here I stole this table from Mark Mutz with the equivalence between the Qt container and the STL container. The equivalent of a Q vector would be std vector. stddq and qlist have the same purpose, but are implemented differently, so I put them in different rows. Std list is a linked list. Forward list is a single linked list. Qvar length array is a very important container, which unfortunately do not really have any equivalent in the STL. The closest equivalent would be the future din array, which allocates dynamic array on the stack. And std array is better than using a C array on the stack. Use std array because it provides safety over a normal C array. You have begin, end, and some API to make your code more readable. So let's compare Q vector and std vector. Both containers put the elements next to each other in memory, and both containers add some memory at the end in case you need to grow the vector. The main difference is that Q vector is implicitly shared. So Q vector is basically just a pointer to the array that contains the metadata and the items, while std vector has all the metadata inline inside the std vector, in the std vector object, and then points to the array of elements. Another difference between Q vector and std vector is that Qt makes cheat a bit and use QDeclare type info. With QDeclare type info, you can tell Qt that your type is so-called movable. So nothing to do with std move, or little to do with std move, but it says that instead of calling the copy constructor and calling the destructor of the old one, Qt can just memcopy the bit in memory. So it's a bit cheating. I think this is technically an undefined behavior, but yeah. Movable, you can declare with QDeclare type info, you can declare your type, and you declare it that it's QMovable type, and then QVector when it's going to relocate because you, if you need to grow or if you need to insert in the middle, instead of calling the destructor, calling the copy constructor and calling the destructor of all the old objects, it will just copy the bit in memory and be much faster. While stdvector can only do that if the type is trivial, which means that it do not have any constructor or destructor. QList. So QList, the difference between QVector is that QList, instead of having the elements directly in memory, it has pointers to the elements. So that means a lot of allocations. Each time you want to put something in the QList, it's an allocations. It's also an indirection. So it's a bit slow. And I don't know if you've attended the talk from Mark Mutz earlier today. You will know that under some conditions, so if the size of the object is smaller than void, and if you've declared your type as movable, then the elements are in the array, just like a QVector. So in that case, the main difference with a QVector is that you have memory at the beginning and the end, so you can prepend much faster in a QList than in a QVector. stddeck, so it's written deck. Oh, I made a spelling mistake somewhere in the slides, but it's called stddeck. It's not DQ, so it stands for double-ended queue. And this has the same purpose of the QList, to be easy to fast to insert at the beginning and at the end. But instead of, so there is one level of indirection, but instead of each element being in its own little case, the elements are grouped in much bigger arrays. And so when you insert an element at the beginning or at the end, it often do not need to reallocate the whole list or to move the whole list. QVarLength array. QVarLength array allocates, so because I'm talking about the container, so I should mention QVarLength array. It allocates the whole thing in, so you specify this pre-alloc is a template parameter. You specify it, and so you say 16, and then it pre-allocates 16, the room for 16 elements on the stack, which are going to be used. If you need more than 16 elements, then it's going to be allocated on the heap, and the stack will be wasted. But so this is a very good container, because in the default case, when you have a little or few elements, it do not do any allocation, so it's very fast. Usually you have those kind of functions, you want them to, they're in a tight loop, you have maybe a few elements to store in an array. The usual case would be a few elements, so you want to have a fast array for that, you don't want to do any allocation. But maybe it's going to be thousands of elements, you don't know, then an allocation is okay, and you're ready to pay the price for that. Just a warning, the default value for pre-alloc is 256, which is quite high. You don't want to waste too much stack memory. So you probably want to reduce that to something that's more reasonable to use to the number of elements you expect. So my recommendation would be to use QVarLength array on the stack if you have lists that are usually small. Use stdvector or QVector, especially if you can call reserve, because then there is only one allocation if you can call reserve. Then the question you might ask is, should I use QVector or stdvector? And that really depends on you. Normally, you're not going to share many QVector or stdvector. You're not going to share or to pass it to any other API. So they're only going to be used by you. It's the way you prefer. If you prefer the Qt style, you can, or the convenience that Qt have, you can use QVector. If you want one of the feature of the STL, like custom allocator or some other feature, you can use stdvector. If you don't want to pay the price for the implicit sharing, then you use std vector. So because implicit sharing implies that every time we need to check the reference count to see if it's shared, and that's a price maybe you don't want to pay. So then you should use std vector. If you need to insert element at the beginning, I strongly recommend to use std-deck because it's optimized for this use case. And because there are so many allocations and so many indirections with QList, I would recommend you to avoid it unless it's necessary to be passed to the Qt API. So the associative containers, there is not too much to say about that. They're really equivalent one to the other. They use the same underlying data structure. So it's really, you can use one or the other just if, again, all the Qt containers are implicitly shared. Therefore, if you don't want to pay the price of implicit sharing, you use the std containers, but in most cases, this is going to be not a problem. Let's talk about Qt for each. So C++11 came with a new range 4. But before that, Qt has this macro for each. And they're mostly similar, but one of the big difference between the two is that Qt for each makes a copy of the container. So it's a macro, and it makes a copy of the container. This is not a problem at all with implicitly shared container, because making a copy is really cheap. But if you have an expense, but if you don't have a implicitly shared, so std vector, this is going to be expensive. It's going to make a copy. So that means that in for each, you can add or remove element in the original container. This won't affect your iterations because you're working on a copy. With a C++11.4, however, it calls begin and end, which might detach your container if it was implicitly shared. So you want to avoid, so that's bad. But it doesn't make a copy, so it takes a reference to the element. So if in U4 you take a reference, you can modify this reference, and this will modify your original container, so you can modify in place the elements while you are iterating the loop. So let's see. std vector, can you use it in for each? So you can use it in for each, but should you use it in for each? No, you should not use it. You should not use std vector in Qt for each. It's slow because for each makes a copy. So for std vector, which is not implicitly shared, it's going to copy the whole container. And so at least one allocation and a copy. And of course, you can use it in the for because it was meant for that. QVector, it's a Qt container. Can you use it in for each? Yes. Can you use it in the range 4? So you can, but be careful because it might detach. QVar length array, it's a Qt container. Can you use it in for each? Yes or no? No, it's one of the few Qt container that is not implicitly shared. So if you use it in for each, it will copy the whole array. But it's not implicitly shared, so no risk to use it in for. So the rules use the Qt container with for each is not always not as simple as that, unfortunately. Yes, there's a question.
You say that QVector might detach. At least the number of QList implementation, it always detaches. But does it might mean here?
So the question is, why is it might and not always?
Always detaches. I didn't know about QVector.
No, so neither QList, neither QVector always detach. They only detach if they are shared. So they only and if they are not const. So if you only have one So if you have your vector, you don't share to anybody in your and most vectors are like that actually. You don't share them to any other part of your program, then it won't detach. The other case is if your vector is const, then the begin and the end function will not detach because they are const. Only the non-const function detach. There's another question?
You said that for each you make a copy of the container.
Yes.
So if you make a modification, for example, on key vector, the modification will be made on the copy of the original container.
Correct. So the question is whether or not if you make a modification in the container within the loop, the modification will be made on the original container. Say you have in your loop, you reference your original container and you modify anything, then it will be modified on the original container and the iteration will not be affected. But if you do it in the range for, then it's an undefined behavior if you add or remove elements while you're iterating in the container. So I'm talking here about adding and removing. If you, yes, but if you modify the element itself, so if you take a reference in the for, then it's going to be modified in place.
It doesn't happen like by the string that they are detaching
So when you're going to modify the original container, it will detach. It will detach at the moment you call the non-const function. So the recommendation is don't use the standard container in Qt for each because it's going to be slow, because it's going to make a copy. And as a hint, when you only use the Qt container in the range for, if it's const and not shared. And you can use this little macro here to make sure it's const. It's a little macro that does a const cast and a bit of C++11 decl type to determine the type of the object. Okay, let's talk about string. What's the equivalent in Qt of std string? I was expecting everybody to say QString, but Q byte array. So yes, std string is really a Q byte array. It's char star with a bit of syntactic sugar, exactly what Q byte array is. So no encoding. While QString is UTF-16. So there is, the equivalent of QString will be std_u16 string. stdw string stands for white string, is before C++11, but the problem with it is that depending on the platform, it would be UTF-32 or UTF-16. Then there are QString_ref, which is basically a reference to inside of a QString, and you also have experimental string view, which is a bit like QString_ref. I'll come to that later. Something I want to say is that Qt has a really good Unicode support. For example, if you want to put a string in uppercase, you might know that in German, this symbol, when you put it in uppercase, it becomes two uppercase S's. So that's how the language works. But the way to do it using the standard library would be to use std transform, which operates character by character. So there is no way you can transform one character to two characters with this API. Qt has a really good Unicode support. It uses ICU behind the scene to support to be fully Unicode compliant, to transform to many different encoding, while it's already hard enough to convert from UTF-8 to UTF-16 with a STL. Then I would like to take an example. Imagine in your function you have isValidIdentifier, and your program says that your identifier needs to be bigger than 3 letters, and they need not to end with _w because maybe that's a reserved keyword. And so you have this function, you're happy, you're calling it with your qbyte array that comes from your QML code, and you're happy, it works. And then you want to call it, you get a std string from some other library that returns a std string. And then you would like to call your function, so you have to convert it, and Qt conveniently have function to convert from one to the other. So that is not so bad, but the problem is that it allocates memory, and you would like to avoid that for performance reasons. So how could you do that? Well, you could make it a template and work both with the standard library and Qt, but that means that you have to implement the thing in the header, and that means that you need to really use the API that is common to both, so it's not really a viable solution. The really solution would be to just take a const char, so it doesn't matter if the const char comes from a byte array, it's the inside of a byte array, or it's coming from the inside of a std string. But then you're using C string. You don't know where it ends. You don't have a nice API on it. It's not so nice. So the standard library, and it's already in C++14 under the experimental namespace. You can use string view. So what string view is a bit like QLatin1String, if you know. It's just a wrapper around a char star and the size, and it provides an API for it. So if you don't need to take ownership of the string, if you just need to do some easy treatment of your string, you can use something like string view. And it doesn't matter if it comes from a Qt container, a standard container, if it's some memory on the stack, or if it's just a raw literal. It inherits from basic string view, and so you have also U16 string view if you want to use UTF-16 string. If you do not want to wait for C++17, you can use QLatin1String, or you can write your own little class string view that can be converted easily from std string or qbyte array or anything. And the goal with that is to have functions that do not require to be in a specific container. So you can mix with different. It doesn't matter if you're calling from a function that uses the STL or a function that uses Qt. Okay, smart pointers. So share pointer, QShare pointer and QWeak pointer are really equivalent to std share PTR and std weak PTR. Qt also provides QShare data pointer and QExplicitly shared data pointer. They help to make implicit sharing. And then we have QScope pointer and std unique pointer that are slightly different. So if just to advertise here the goal of the smart pointer, those are those functions taking ownership of the QGraphic item or of the Q menu. It's not easy to say, but if you explicitly write in the code with std unique pointer, then you know this function takes the ownership of my object. Or if you return a value with std and unique pointer, you know that you need to delete it, or I mean, you don't need to delete it because it's going to be deleted automatically, or you need to somehow take the ownership of it. So it's very explicit. You avoid most of the leak with that by specifying with the API whether or not you want to transfer ownership or not. Unfortunately, as you can see, I used std unique pointer here, but I cannot do that. I cannot do the same with QScope pointer. The problem is that QScope pointer is not movable by design. So the rationale is that the name is QScoped pointer, so it has to be scoped. You cannot go away with it. So it is not supposed to. There was some discussion in the mailing list whether or not it should be movable, and it was decided not to. And this very convenient vector of unique pointer, you cannot do that with a QVector or QScope pointer for two reasons. First reason is that QScope pointer is not movable, and even if it was, QVector do not support. QVector needs the objects to be copyable, which unique pointer or QScope pointer are not. They're not. You cannot make copy. You can only move them, and QVector needs that you can make a copy of the type it contains, even if you don't. And so that's a very good reason to use std vector instead of QVector in this particular case, because you often want to have a kind of list that owns the memory and that automatically releases it, so you don't have to call qDeleteAll in your destructor or forget it. Threads. Should you subclass QThread or not? A question that everybody asks, and I'm not going to answer this question in this talk, but I'm just going to offer another solution. You can also use std thread. So if you use std thread, all the features that you're used with Qt, like signal and slots, qmutex, qthread storage, anything, or I think anything will work with std thread just as it works with a Qthread, because Qt will automatically create a Qthread that represents this std thread. And also all the threading primitive like std mutex, condition variable, and so on also work with Qthread.
Is there any benefits?
So the question is whether or not there is a benefit of using std thread. I would recommend to use Qthread because if you're in a Qt API, Qthread is good, right? But if you're going to mix with another application that uses std thread, or I mean with another library that uses std thread, there is no problem with it. Or if you prefer using the std thread syntax, you can also do it. I think it doesn't really matter. It's just a question of style in this case. So there is two ways to. So here I have a small example of like typically this is the case where I do an I compute the Fibonacci number in a thread, and then I can emit a signal from my std thread when it's ready. And this will just work. So in this other example, here I just create my std thread. I instantiate a Q event loop in it, so I can use timers and Qt connection and anything, and then I can have a worker object. So here the this pointer is like the object from which the function is called. So I don't know in which function we are here, but for example, in that case, this object was my object, which had a result ready signal, and same here. And as you see, I call qthread quit, and even though it's qthread quit, this will basically end this event loop and quit the std thread. Otherwise, the standard library also will also compete against the files qfile iterator, qfile info in C++17. Also competes against the network library, Qt network. There will be an equivalent from the standard library. So the question is, is Qt network still relevant when the standard library, which everybody will have normally, will have networking? Well, we'll see about that in a few years. So what's for the future? Can we, or should we, probably in Qt 6, the Qt algorithms that are already deprecated might be removed. Should we get rid of the container? So that's the big question. is this ABI guarantee, is it worth it? Some people say it is, some people say it's not. We're probably not going to get rid of the container for source compatibility reasons. Even in Qt6, we don't want everyone to rewrite all their code, so it's probably going to still work. So we are not even talking about Qt6 yet, so maybe this is not going to happen. We don't know what is going to happen, but it's open questions. I have a last slide about mock, because as the mock maintainer, often people complain, oh, why do you have to use mock? It's not standard and so on. But it's orthogonal to the use of the standard library. In my opinion, mock allows to have a nicer syntax. Up to the day that we will have reflection in C++, we're still going to need mock, and so it's here to stay for a long time, in my opinion. So the conclusion is that you should not be afraid to use the standard library in a C++ program. I hope that if you were afraid to use, if you were totally not willing to use it, that now you see that it's compatible and that you can use. And I hope that this talk gave you more understanding of the differences between the standard library and Qt. I think I'll post my talk on Twitter today or tomorrow. I'll post the slides, a link to the slides on Twitter today or tomorrow. Thank you.